Hey everybody, good morning from the East Coast of the United States, and this is Andrew Bowker speaking. I'm an offering manager at IBM, and today with me presenting, I also have Larry Strickland, who's the Chief Product Officer at Data Kinetics. I'm coming to you live from my office, which is also doubling as a baby's bedroom, and I'll be speaking to you a little bit about tailor-fit pricing and in-memory optimization and presenting a solution that may be viable for everybody to implement rather quickly. So that is what I'll be talking about, and you'll know I'm done talking when you hear the Australian accent come in, which will be Larry, who's going to do it, who's going to do a deep dive on some of these in-memory optimization techniques. So with that, I will get started, and I will jump right into tailored fit pricing. So this is just something we'd love for you to participate and chat with us through the Zoom app, and let us know where you're at with your journey to tailored fit pricing. So some of you might be out there and you might have no clue what tailored fit pricing is at this point, and that's totally okay. Some of you might have just heard of it and you're considering adopting tailored fit pricing. Some of you have probably evaluated it and determined it's not the best step for your organization. Or some of you might have plans to transition to tailored fit pricing, or you're already on tailored fit pricing and you're eager and pursuing other optimization strategies to lower your consumption. So I'm always just curious where the crowd stands that we're speaking with. So I'll give a minute for people to chat back, and forgive me, I can't really see the chat in the presentation screen that I'm looking at on Zoom. But Larry, do you see anything coming through?
Yeah, so we've got one response from, I guess it's Guy, no plans to move to TFP.
Okay.
And Jim Horn has reported they're on TFP. So.
Okay, so the whole spectrum there. That's funny. That's the two ends of the spectrum. But I will say, we typically see most people in the middle, right? So we've evaluated it and we're determining what the next steps should look like, or we're considering adopting in the future. So whether you're not on it or whether you are on it, like Jim who responded, then this presentation should be really helpful for you to understand maybe some new techniques and new things that maybe you haven't thought about yet in terms of in-memory optimization to help you lower your tailored fit pricing consumption. So let's take a step back here and talk about some of the changes that have affected all areas, all industries across the globe. So as we know, these big companies have changed tremendously in how end users interact with their technology, and so we call that process, we've coined that as digital transformation. So, maybe you think about 10 to 20 years ago, you used to walk into a bank and speak with a teller and have a physical engagement. And then maybe 5 to 10 years ago, you were more into telebanking or web banking. But now, I don't know about you, but now I do pretty much all of my banking on a mobile app. So I can be on my mobile app anywhere in the world at any time and access and complete transactions on my phone. And so for you to think about that as a consumer, we just have this insane ability and accessibility to our technology and to the companies that we interact with that service us on a daily basis. So that's as a consumer, but now kind of think about as a IT provider, that ease of access has led to a really hard time meeting those demands, meeting those changing end user demands. So you think about all the things that can affect demand, like for instance, weather. Like if weather can send a system into orbit just by you have all these people flying, millions and millions of people flying around the world. Well, typically you do, not during COVID, of course, but typically you have people flying around the world. Weather change happens, a typhoon's coming or a hurricane is coming, and Now you have to channel all that web traffic and workload through a system that that may or may not be able to handle the spikiness of the workloads that are coming through. So you have these workloads that are not only spiky, but they're unpredictable based on dozens of factors out there that create hard to manage IT systems. So as we're moving into the world of hybrid cloud, we see that these systems are just becoming more and more difficult and to manage. So over time, those trends were mirrored in the way that we did pricing on the mainframe. So back in the day, it was simple and straightforward. You bought a machine, and the software was licensed to run against the size of that machine. And over time, we found that people were more interested in finding a machine where you can have a more granular way of pricing. So workloads evolved, and people wanted that deeper level of granularity. So the subcapacity model was born, and that subcapacity model was more or less focused on the 4-hour rolling average, which is what many of you are probably familiar with. But it's that peak period where we're trying to optimize the top of your 4-hour peak of consumption. And what we were seeing, more recently now, is that peak is actually more and more difficult for people to manage because of that unpredictability, because of that ease of access, because of the way that end users are interacting with our technology that we offer to them. And so we were seeing that this could be a limiting factor for some of our customers. And so that was the reason for last year introducing tailored fit pricing. So tailored fit pricing, now the aim is to give a greater alignment to spikes and unpredictable workloads by basically allowing you to run your machines and run your systems and run your workloads at any level throughout the day, throughout the year, throughout the week. So now, to get into exactly what tailored fit pricing is, I mean, in the 4-hour rolling average, really the only thing that determined your pricing was that peak. And so wherever the peak was what you paid on your MLC licensing. And so if there was 10,000 MSUs consumed, you only paid based on that 2,400 that was consumed during that 4-hour peak. So, but that unpredictable aspect of the peak sometimes caused issues with you being able to forecast your cost and other issues based on based on how you're able to license out your software. And so now that tailored fit pricing is on, it's kind of like a tap. You turn on the water comes out, and you pay for what you consume. So now with tailored fit pricing, it's a much more appropriate, we're finding a much more appropriate metric with the way our modern workloads are today. So, in both of these graphs, in both of these scenarios, you're consuming the same amount of MSUs, and instead of trying to optimize around the peak like you normally would, you're now optimizing all of the 720 some odd hours in the month. And this dives a little bit deeper into that. So there's a few more opportunities for customers who are looking into tailored fit pricing, and for them who have moved over to this model. Most customers that we talk to are trying to do optimization to make their workloads not only around the peak, but anywhere in the month, the 720 some odd hours in the month, depending on whether you have 30 days or 31 days in the month. They're looking to optimize in all those scenarios. So it's tough to tell on this graph, but up here you have the peak. This is the dark blue line, and this is where you would normally look to optimize your workloads, your applications, and all the other systems that go into your Z estate. But in tailored fit pricing, now you might have previously ignored areas where your consumption was higher than your actual 4-hour rolling average. So where your light blue line, your consumption is higher than your average, your consumption is higher than your average. Those are areas where we can look to target for you to lower the ability or lower the workloads and bring down your consumption in those areas as well. So it's expanded the view for you to be able to unlock new opportunities and find hidden potential to lower your consumption and basically lower your cost on tailor fit pricing. So what we're going to do is we're going to dive a little bit more into what that optimization could look like. And for those who are still on 4-hour rolling average, like I know we had one chat come through where that was the case, you can still optimize the peak. And this technology that we're going to introduce to you, do a deep dive on, is still totally applicable to the 4-hour rolling average model. But especially for tailor fit pricing clients, this is something that we can always be thinking about is if you want to get the most out of your Z systems, optimization is always going to be important. And so moving into that a little bit more is I like to give a bigger view in terms of my job is to set up the view and the why we should care, right? And Larry will dive into the technical details a little bit deeper. But one of the big reasons I think we should care is I saw this report last year from IDC that said, this past year, that says, for the organizations who are investing in the mainframe, they're seeing a 6x return on their investment, which is something we probably all know to be true. It's just half the time it's hard to get the budget for some of these projects, and it's hard to figure out where you should be investing those dollars. So one of the things that they dove a little bit deeper into is the opportunities out there for where that ROI exists. So where can you grab that ROI? One of them is in the way that you are managing your workloads, creating new revenue streams, creating new business opportunities through expanding and optimizing your workloads. Another one is through cost savings. So when you're optimizing your systems, the efficiency of your Z estate becomes that much greater and that much better. So they're seeing cost reduction. And then the last thing they're seeing is skills improvement. So when you're able to optimize your systems and potentially automate some of the things that you were previously doing manually, well, now you have this more efficient way of managing people's time. And so that's where the ROI is coming from, and that's the opportunity. But a lot of the people we talk to, they're seeing some of these things blocking them from capturing that opportunity. And so I'll quickly walk through some of these because I'm sure you're all somewhat familiar with each of these. But in the way that we need to optimize our workloads and applications, it stems back to what we talked about earlier with more volume, less predictability. Your applications span across all sorts of mediums, whether it be mobile, batch, web, etc. And if any of those workloads falter, that could mean poor end user experience, which basically reflects poorly on your brand. And then in the need to optimize cost, your workloads are increasing, your budgets are decreasing. You might have misalignments with some of the business priorities, IT and business priorities. Sometimes they're aligned, sometimes they're not completely aligned. But then it just leads to all these operational inefficiencies, and you might have a mandate coming down from your C-suite, trying to understand how you can cut costs while also having your resources cut. And then we're all familiar with the generational shift and the velocity of change happening on the mainframe. And so it seems like a lot of the customers we talk to are always in the process of putting out fires or figuring out ways that they can reallocate resources to whatever the need of the hour is. And so that really cripples your innovation. So if you're not able to free people up with these great skills to be able to think and do things that really add value back to the business, then that could really cripple your forward thinking as an organization. And so another opportunity for you guys to chat with us. Which of those do you feel like you struggle with or your organization struggles with? Sometimes we get not one, not two, but all three. And sometimes we get, we're really just constrained by the budgetary aspect. We're being asked to do more with less. or sometimes you're just your workloads are just getting out of hand, and trying to manage that could be a challenge. And then sometimes we're just losing skills, whether it be to retirement or to other organizations. So I'll give a couple seconds for this to come through. Larry, is there any chats coming through? I'm always curious to understand where people are.
Yeah, no, so we've got one response with cost.
Yep. Okay.
And by the way, we did get more responses from our question this morning. I think it took people a little time to find the chat window. Yeah, we've got 2 votes for cost.
Okay.
Cost is definitely an important one here.
That's good. Yeah, that's good. So cost is definitely something that we'll dive deeper into here. So one thing is for sure is that there are so many different solutions out there to optimize on the mainframe and to optimize these challenges, like these cost challenges or skills or workload challenges. And today we're going to focus on one that could address all three, and that could be a game changer for you. So this is where we've found a lot of quick wins for those who have moved to tailor fit pricing and they're looking to optimize and save cost. We found that this in-memory optimization technique can be a very quick win for you to be able to quickly save cost on the mainframe. So I'll introduce the tool to you and give you an example of how this works, and then Larry can kind of dive into the technical details of it. But one of the tools that we use is called IBM Z Table Accelerator. So it's an in-memory table accelerator for DB2 and VSAN that will dramatically improve your Z application performance and reduce that operational cost. So the way the table accelerator works is that it uses a much shorter code path to access data in the way it calls your DB2 and VSAN tables. So by taking that shorter code path, you're saving time, you're saving money, capacity, and so that really frees up resources and your workloads so that you're able to focus on innovation and focus on those other projects and spend less time worrying about costs. So, a normal path might take multiple stages of buffering to get to your table calls, but with these high performance in memory tables, it takes that direct access path and bypasses a lot of that buffering. So we're targeting really frequently accessed data, reference data, and Larry will dive a little bit more into that. And so one of the things, just to lay this out clearly in terms of the benefits, so that you understand the benefits of the technology that we're describing, is that you're going to be able to reduce resource consumption. A lot of times in batch windows, you're going to be able to reduce elapsed time. And then which reduces, operational costs and improves system capacity so that you can reallocate funding to more innovative projects that you've been meaning to tackle. So one of the examples that we've seen this really shine is in a really large US bank. So they've had this technology for about 20 years now. And at the very beginning, they implemented this into their implemented this technology into the fraudulent credit card application that they had. And so if you think about these really big banks, every time you swipe your credit card, they're needing to reference against a table of all the known fraudulent credit card numbers that they know about. And so that little transaction happens every single time somebody swipes a card. So which is millions and millions of times per day. So they have to make that reference table call millions and millions of times per day. So we're targeting that little call there. And by placing that table in memory, they were able to reduce that call by 97%. And if you can imagine 97% on these little table calls over and over again, millions of times per day, added up to some pretty significant savings for them. And so they saw some really significant savings in that particular application and decided to implement this technology across the board wherever they could. And now today they estimate that it touches about 7.5% of all of their programmatic code. So it's a robust technology and a robust solution for them. And so it all started with that one opportunity where they really struck gold, and it became a game changer for them. So with that, I will hand over to Larry, and he'll dive a little bit more into the details.
Good afternoon. Good morning for those of you who I see who are actually in North America at the moment. I'm based in Ottawa, Canada, and we actually have snow on the ground outside, although a promise of a warm weekend should see that all gone. So IBM Z Table Accelerator is what we're going to be talking a lot about for the rest of this presentation. It is what we refer to as a high performance in memory technology, and it's going to leverage the mainframe's memory. We've got customers who are using this to accelerate batch processing, typically where you've got a batch window contention challenge or just a desire not to have a long batch window at all. Accelerate online processing. This is typically looking at response times or worrying about SLAs being violated. Accelerating the database in either case. And it's doing this by accelerating access to specific sorts of data, not any data, but specific sorts of data to optimize workloads. So I always find it useful to actually look at the memory pyramid on the right. At the top end, we got the core cache that's really close to the processor, very fast, very small, although growing with each release of the Z systems, but it is very fast. And anything's retrieved from there is retrieved extremely fast. At the other end of this, we have the tape, the cloud, the long-term storage. This is typically the largest amount of data storage. It's also the furthest away. It's probably the cheapest, and it also takes the longest to retrieve data from. So depending on where your data is, the longer it can take to retrieve, but maybe it is going to be stored at a cheaper rate. So typically we're looking to, from a performance point of view, we're starting to worry about where in this pyramid our data resides, and whether that makes sense to actually move data up the pyramid for particular scenarios in order to improve the overall performance of our applications. Clearly, any data moved up is going to be faster to access and will optimize an application, but clearly there is a cost associated with trying to move everything up into the core cache. You just need such a big one. It's just impractical to do. And some of that data isn't accessed that frequently. So the benefits of doing that is lesser than other sorts of data. So we do spend a lot of time looking at which data we should try and move up this pyramid in order to improve performance. Next slide, please, Andrew. Yeah, okay, so all data ultimately does end up in the cache. It's just a matter of when and how we get it there. So yeah, you can move on to the next one. I've already talked to this one. So one of the things that many applications do is they buffer data. So typically databases, whether it be DB2, VSAN, etc., they all have versions of buffering. And what this does is essentially taking data off disk and putting it into the memory, system memory. This helps a lot because that I/O, or the pause to do the I/O, can take a lot of time. And actually, while the programs wait, the CPUs are actually going to switch out and do something else. So then you have these switching of context happening in the CPUs, which can also increase the inefficiency of the system. So moving stuff up in memory really helps. It is moving it closer to the CPU. It's not moving it all the way to the CPU, but moving it out of the disk and into memory really helps. I'd also note that there's different disk technologies that can change the speed as well. There's also often buffers within the disk. This is great when reading sequentially off a disk. The buffers on the disk can really help improve performance of reading off the disk. So there's multiple levels here. I like to think about it this way as we try and move stuff up the pyramid most efficiently and for the right reasons. So next chart, please. So when we start looking at some of the high performance techniques, particularly as used by IZTA, we start shortening the path to access that data. And this often is looking at very small pieces of data, not large pieces of data. Often when you're looking at buffer pools, increasing the size of the buffer pools in DB2, for instance, you can actually throw a lot of memory at that. It's a lot of system memory, and getting that data in there is very, very good for performance, primarily moving that information from disk to system memory. However, when you start looking at high performance, you're typically looking at much smaller sets of data, such as, to Andrew's point, the table that contains the fraudulent credit cards. This is often a much smaller amount of memory than maybe stores in your database in general. So getting that access more frequently tends to have that particular data set start to appear in the cache more often. The more often it appears in the cache, the faster it's going to be retrieved. This really is a second order effect. The high performance technology will trigger. So we see the data appearing in the level 3, level 4 cache more frequently. As a result, we see a better performance there. The other thing we're doing is taking full advantage of an a priori, so a prior knowledge that the data will be in memory. We know ahead of time that the data has to be in memory because that's where we put it. And as a result, we can shorten other cycling times in order to retrieve the data. And that's where we see those 30 to 100 times faster than alternative mechanisms, because we've made the assumption that the data will be in memory, we've ensured it's been in memory, and as a result, we see this much higher performance. Next chart, please, Andrew. So a image of what is trying to happen. So typically, IZTA, what it's doing is, as I said, it makes the assumption that the data is in memory. It can direct calculate where it is in memory with simple math and retrieve that data very fast. Comparing this to other database management systems, and I won't, hold on, I gotta be careful there. Comparing this to a database management system. So IZTA is not a database management system. It is a table management system. It is just managing in-memory tables, nothing more, nothing less. As a result, there's a bunch of functions that it doesn't need to do or doesn't do that you would often do within a database management system. So whether those events occur or not, at least the option for those events to occur or not gives a much longer code path for many of the other management systems. And as a result, we see a much faster, much less CPU required to retrieve a single row of data. So typically, in DB2's case, we're looking from 10,000 to more machine cycles required to retrieve a simple row of data, where IZTA is looking at around the 400 machine cycles to retrieve a simple row of data. So again, it takes advantage of the fact that it knows ahead of time the data will be in memory, and it also takes advantage ahead of time that it's going to, because it is in memory, you've got a simple mathematical calculation, and you can ignore a lot of the other functions that may occur in a database to actually retrieve that data much faster. And we're typically looking around 20 times faster to do so. And that will, when used carefully, have a huge impact on the performance of particular applications. So some examples now. So both in online and batch, we've seen substantial reductions in CPU used, and probably even greater reduction in elapsed time by using this technology. So we've seen batch windows that used to be 8 hours long run in 15 minutes, and we've seen regularly 30% cut off the top of a online transaction. Obviously, results will vary. And as I said, we are looking for very specific scenarios where this technology can be applied, where that small amount of data in memory can make a huge difference on an application's performance. So here's another actual result. This is actually a VSAN file. The issue here wasn't the VSAN file was getting read a lot, although it was getting read a lot. We did see huge gains from reading from in-memory versus reading from a VSAN file. However, the bigger change here was the fact that this file was being opened and then closed again by multiple jobs. So by pinning it in memory and giving access from to the applications from directly to memory, we saw a massive reduction in CPU and an even bigger massive reduction in overall elapsed time. So this particular sample run went from CPU of 4.74 seconds down to 0.21 seconds, and the elapsed time went from 49.6 seconds down to 0.7 seconds. So both drastic improvements. When this was applied over the course of an entire day, though that reduction in CPU requirements actually was more than 24 hours of processing over the course of an entire day. So spectacular results for the right scenarios. Next slide, please. These are performance metrics between IBM ZTable Accelerator and DB2. Again, we're only looking at very simple table reads. And again, we're assuming that we can pin that data in memory and just provide direct memory access to applications to that data. When this occurs, we see substantially improved performance results for retrieving simple rows of data. Depending on the organization, we see slightly different ones. The other thing is that we note is the ability to insert records into the memory is very fast as well. So we see spectacular results in doing that. So as a result of that, we typically are looking at two sets of data. And I'll come to that in a couple of slides. So we talk about reference data and we talk about temporary data. Next slide, please. So when we can also look at VSAN and CICS managed data tables, and we'll also see acceleration there. So in the case of VSAN, from a CPU consumption, we're seeing about a factor of 4 reduction, which is really good. I showed you much better results before for VSAN, but that was largely because of the open closing of the file. In this case, this is not considering the opening and closing of the file. It is just purely looking at the read performance. And as you can see, it's about 4 times faster. In the case of CICS managed data tables, we're looking for something in the order of 3 times faster compared to but when using IZTA versus CICS managed data tables. Next slide, please. So what data fits best? So typically, as I said before, there's 2 types of reference data. 2 types of data that we use here. The first one is reference data. So reference data, depending on your industry, depending on your processing, will vary what portion of your data is actually reference data. But this reference data, it might be states of the union, it might be countries in the world, it might be interest rates, it might be credit card types, it's a very common one, or it could even be the fraudulent credit card table that Andrew was referring to earlier. This is reference data. It's relatively static, as in it doesn't change. It can change, it just doesn't change. However, the important thing is it's read very frequently. So that very frequent read, even if it might only be a very short time to execute one read, because we're seeing millions or even billions of reads per day, each one of those little gains adds up over the course of the day. So significant savings over the full run. The other set of data we often look at is temporary data. So this is created, processed, and then deleted. So it doesn't matter whether it's a COBOL internal table or CICS managed data table or other techniques. Often we see data is created for the purpose of processing, generating a report, summarizing a table. It doesn't matter what it is, but this table is created, searched multiple times, and then are no longer needed. Again, IZTA, because of its high insert performance and high read performance after organization, it can be very useful in that particular scenario to improve performance. So a typical IBM ZTable Accelerator implementation, if we're looking at reference data in this case. So when we're looking at reference data, we're going to take a copy of that reference data and put it into IZTA. IZTA now has the advantage of knowing this is in memory. It can use straightforward math to retrieve data from in memory, and as a result, it can do so very fast. The batch or online program then would read the reference data directly from IZTA rather than the permanent store. And because it can do this much faster, and also many applications actually spend more time reading reference data than they do other data, you can see a massive opportunity for performance improvement because we can access this data so much faster than we can the data on the regular store. So what are some of the customer results look like? So in this case, a large credit card processing company. The company, the processing still exists. The company doesn't exist anymore. It's actually been sold, or this group has been sold multiple times. The technology's gone with the sale each time, but the processing benefit in credit cards has been repeated time and time again. So in this case, the specific problem was a reconciliation batch job. So this is a batch job that's run every night to reconcile the transactions from the previous day. This runs every night. In this customer's case, it was taking about 8 hours to run. This is really putting a lot of pressure on the batch job. And the job ran through the transactions of the previous day, but associated with that large table that held all the transactions of the previous day were a collection of little tables. I believe there's about 8 of them. And those 8 little tables describe the credit card types, and as a result, describe the type of processing each transaction had to go through. So those credit card types could have loyalty programs, could have interest rates, could have brand recognition, things like that. They were all associated with the credit cards. And I think they had about 100 credit cards at the time, 100 different credit cards at the time. So as a result, each of those smaller tables held approximately 100 rows each. 100 rows, 1,000 rows, in that order of magnitude. They were relatively small tables compared to the number of transactions being executed. So the solution was to take those smaller tables, pin those in memory using IZTA technology, and then rerun the batch job. So that batch job that used to take over 8 hours to run, that was able to complete in 15 minutes. So there was CPU reduction, but actually the primary reduction here was the elapsed time. 8 hours to 15 minutes, obviously a spectacular result. And although you end up in that situation where the managers start complaining that there's obviously a problem because the report came out 8 hours ahead of when it should have come out, or when it normally came out. So anyway, that's a good example. I'll give a couple more. In this case, VSAN processing. Actually, this was I showed the detailed results earlier. So in this case, a VSAN file had a very high number of open to close. It also had a high read rate, but as a result, it was driving a high CPU usage. So a solution was to take that VSAN file, put it in memory, access it from memory directly. We removed the cost of the reads, but more importantly, removed the costs of the open and close. So results that 93% reduction in CPU, a greater decrease in the elapsed time. So in this case, 98%. And when projected over the course of the day, that was a 24-hour reduction in CPU. So you could literally turn off a GP by adopting this technology for this specific use case. So this is a temporary table case. This is a large bank in the US. They had a COBOL program that generated an internal table, so COBOL internal table, and then performed multiple binary searches against it. The search code, best guess was around 1.25 million times, had to be searched, and it was searched 4 different ways. The job took over for an hour to execute, an hour of CPU to execute this. However, when we move that table from the COBOL into IZTA and replace those 4 searches with IZTA search methods, we saw a 98% reduction. So that job that used to take over an hour to run ran in less than a minute. And it was primarily because there was 4 different search mechanisms required against the table. IZTA is very efficient across multiple different search mechanisms. And as a result, we saw a huge performance improvement there. So another good result by applying the technology in the right spot. So where is it applicable? We have a number of customers who have been using this for a number of years. I think Andrew gave the example of a bank that have been using it for 30 years. As a result, our customers get very creative as to where and how they can use the technology, and there are multiple very interesting circumstances out there. Without a doubt, the easy ones to start with are typically going to be what we call reference data tables. So the example is given before, and it doesn't matter whether it's batch or online. We're going to be reducing the batch window contention, we're going to be reducing the elapsed time of a particular transaction, and in both cases impacting the CPU resource usage, which can give you a quick win. In the case, if you're on rolling 4-hour, obviously you're going to be looking at this during the peak period of time. The huge advantage of TFP is you can now look at I think it was 720 hours Andrew mentioned, where you can reduce that CPU resource. So, quick wins across a full 720 hours can be quite significant for an organization. Also, the temporary data tables, we have a collection, sorry, Andrew's slightly ahead of me, yeah. Temporary data tables. We do have a large number of customers that are using them for temporary, whether this be online transaction temporary data, or whether it just be for the generation reports. We do find a lot of customers using temporary data tables without the need to persist, just storing stuff in memory for ongoing processing and then not requiring it afterwards. The last one, programmable flexibility. This is something that surprised us when we went out to our customers and looked at whether we're using it. We have many customers that have implemented processes that enable them to change the processing. They're processing on the fly. This is typically a set of rules. These rules are reflected in data that control processing. The downside of putting rules in data is each one of those rules needs to get read every time an application's running, so it gets read very frequently. The advantage of ICTA in this circumstance is because the data is being read very frequently, and often these rules aren't huge in size, we can put those all in memory, execute the programs directly accessing these from memory, and see a huge performance gain while still giving the customer this programmable flexibility. So huge benefit there, where other technologies might slow down by providing that flexibility. IZTA has proven multiple times that it can speed things up. So the question is this a good fit for me? So if you can check these boxes, so we're looking at DB2 or VSAN for data sources. It doesn't mean our customers aren't using IZTA for other data sources. It's just that with these two, we typically can find cases where it's being used more frequently. Highly transactional workload. Analytical workloads do not tend to have the same circumstances where we have a fit, so we are looking for highly transactional workloads. Typically, there has to be a goal to reduce costs or fix a batch window contention or reduce online response times. That goal obviously has to come with a business case. If there's no business case, there's no point in moving forward. But with that goal and IZTA being able to meet that goal, there's obviously reason to move forward. And the last one is the applications have to be developed or at least managed within the organization in order to leverage the new technology. So if these all appear true, then you can work with an IBM representative to find out whether there are some quick wins, some low-hanging fruit that maybe can be uses technology to improve your performance. And again, we're looking at different circumstances depending on the licensing you're on. Obviously, in TFP, we've got a broad range of opportunities where if you're on a rolling 4-hour average becomes a little harder. We have to focus in on that rolling 4-hour, but remember, when you are looking at the rolling 4-hour, you're often playing whack-a-mole. So you may be looking at multiple different peaks throughout the course of the month to optimize and bring down that peak session, that peak amount of processing that's driving your primary costs.
Thanks, Larry. So I will wrap us up here and just kind of dive a little bit more into what that looks like. But We do, in order for you to find what that quick win looks like, we do have this application performance assessment that we offer to clients who come to these types of sessions, where we'll basically send you a quick set of instructions. It's like 1.5 pages long, and that set of instructions includes a data collection script where you can collect data from your DB2 or VSAN systems, and then you'll send it back to me, and we'll analyze it for you and present to you where those low-hanging opportunities lie, and where you can potentially get some quick wins for lowering your consumption in terms of your DB2 and VSAN tables. So that is a little bit about how that works. And yeah, that would be my we're about to wrap up here, so that's really my call to action for you, is reach out to me. I have my email on the screen if you'd like a application performance assessment to understand what this looks like for you. Hopefully you learned a little bit about InMemory during this presentation. You learned a little bit about behind the scenes and why it matters, and you learned a little bit about tailored fit pricing and where you can improve in at least one way and optimize your tailored fit pricing operations. So I really appreciate your time on behalf of Larry and I. Thanks for attending today. And we do, I believe, have a little bit of time left for questions. So I think Gino, our
So
chair,
if there
should be
are any
able.
questions,
Go ahead. Go
yeah,
ahead,
if
Larry.
there are any questions, people can just push them into the chat. Ask your question, or at least raise your hand in the chat, and then we can have you unmuted so you can ask your question. Okay, so we're not getting any questions. We'll remind everyone to submit the session feedback form. The other thing is remind everyone that there is a charity. Many of you are participating in this conference for free, so certainly consider strongly that you make a donation to the charity through the GuideShare Europe. I know they've been very successful in prior years, raising a lot of money for various charities, and I definitely encourage that. I know I've got a number of staff members that will be attending various sessions, and as a result, we're doing a corporate. We're going to be making a corporate donation through GuideShare to the charity. Actually, I'm finding that telling my staff that if they attend a session, it will increase the amount of money being donated to charity is actually motivating more of my staff to participate in these sessions, which is great. Sharing the knowledge on ZOS is always a good thing. So.
Hi, Larry. Hi, Andrew. I've just had a look at the questions so far. We haven't got any come through. So thanks for closing as well. So if you're happy, then thank you so much for presenting, and thank you to all the audience for joining as well. We really appreciate it.
Good. Sounds like we answered them all in the presentation then.